Hello, Gabriele. Great to have you here. For those who may not know you, could you please tell us about yourself and your expertise?
Absolutely. Thank you. I'm Gabriele Manganaro. I work at MediaTek as a director of technology. Um, Prior to MediaTek, I worked at Analog Devices for many years, and also in the past, I worked at TI and National Semiconductor. My area of expertise is data converters, particularly high-speed data converters, and I've worked in the broad field of analog and IC design for decades.
Excellent. Thank you. What's the motivation behind your upcoming course and its relevance to our semiconductor industry?
So I'm going to be covering gigahertz DACs, which are found on all modern communication systems, from wireless to wired communication systems, such as cellular base stations, smartphones, IoT, high-speed SerDes interfaces, which are now becoming a bottleneck in AI infrastructure systems. As well as high-end instrumentation, tactical systems, and so on.
What are the main features of the course?
We will be covering many aspects of the design of high-speed DACs, including architectural fundamentals, impairment analysis, advanced mitigation techniques, design trade-offs, and we will also cover quite a few case studies, discuss about design trade-offs, including layout, floor planning, simulation techniques, which are seldom found in the open literature.
These high performance stacks that you're expert on, they can be quite unforgiving to design, especially you just mentioned layout, floor planning, and because these smallest imperfections can appear directly at the output and severely degrade performance. Would you like to maybe expand on that?
Yeah, that's absolutely true. The DAC output is a continuous time signal. So any glitch, any imperfection that arise from both the transistor level design, but especially the physical implementation, the layout, will inevitably show up in the output and have an effect on the spectral purity of the DAC, which is one of the most important specifications. So, for example, RI drops on power lines and other interconnects, or, for example, uneven connections, lack of symmetry in certain structures. All of that will really reflect into the waveform that the DAC is synthesizing, and therefore will have an impact. So it's very important to really correlate, even at the intuitive level, that if I make certain choices, or if there are some imperfections that arise from manufacturing, I will see them in the output. And so this is very important also to recognize immediately during the design, but also to be able to simulate it and to know what type of simulations can truly
Mm.
surface these potential problems.
The two design projects that are shown there, they are they're high performance specifications. What can the participants expect from these design projects? What will you be covering?
These are designs that normally will take several months or even longer. Nevertheless, in the two sessions that we will dedicate to the two projects, we will really put a little bit PowerPoint on the side and really run cadence and really show representative circuits of um, uh, designs of this sort. We'll talk about again real simulations. We'll talk
Mm.
about some real circuits, and as you can see, there are two two examples here. One is a 14-bit 1 gig sample per second D2A. So it's a bit of a high resolution fast DAC, which is suitable for wireless applications. The second design, it's a bit complementary to the first one in the sense that it's a lower resolution, but much higher sample rate. So this is much more in line with the modern wired and SerDes applications. The trade-offs are different in each case, and so we'll compare some of that. What people should really expect is really we will focus on first principles. We'll talk about representative circuits. We'll really talk about simulation techniques, which can be very time consuming. And so you kind of need to be smart about it. And we will really look into that aspect. So that's really meant to give you a real feel, which again you won't really find in publications.
In your opinion, what's the target audience for this training course?
So in terms of let's say prerequisite, an attendee for a course like this should have a good foundation on analog IC design. That being said, it's really intended for a broad audience, ranging from graduate students, which really want to deepen their understanding of this type of systems, but even seasoned practitioners, which really are approaching the subject for the first time, or even they have had previous experience with this type of circuits and want to broaden their views or want to deepen certain topics. So I would say really everyone will find something very good, very useful in a course of this sort.
Well, thank you so much, Gabriele, for your time, and we're looking forward to your course in September.
Thank you so much. I really look forward to it as well.